So I think my math lab was down for a while. So I extended the due dates on the quiz in 13.4 and 13.5. People requested extensions on 13.3, but I don't think there was a homework on 13.3. Right? So I figured they meant 13 something else. We're covering 13.6 this week. It says 13.7 is due. Like we look at the syllabus. Syllabus doesn't make any sense to me because yeah, exactly. So I'm guessing that like 13.7 isn't going to be on the exam, probably not on the final. But I don't know. It could be on the final. I don't know for sure. It's the first time I've taught this class, so we're going to just go ahead and finish 13.6 today and start 13.7. So we'll knock it out by probably Friday. That way we just have the rest of the semester to review for the final exam. All right. In which case, the last class requested, let's see, our section 2, that like the practice exams, like for the last whatever, because you can't access them once they close, right? So they asked that I open them back up till the end of the semester so we can use those for studying or whatever. So I'll change that to something like the 12th. And then you have what? Got 2. Remember, I'll open that up, and then we do have a practice exam for exam 3. So Monday we'll do the practice exam for exam 3 because exam 3 is Wednesday, next Wednesday, a week from today, right? I'll just make sure that's open for a while. Yes, I did extend the quiz. Where is it? The quiz 5, I extended it to the 18th, which is a day after when quiz 6 is due. All right. So quiz 6, when does it open up? Tomorrow? Oh, yeah, quiz 6 will open up tomorrow. 6 a.m. to 6 p.m. All right, y'all can handle that, right? I'll probably end up doing an extension on that as well. All right. Did I just extend it now? Quiz 6. Let's give you like over the weekend to do it. How's that? That's better, right? I don't know. I've seen it. I have no idea. I just hit update, so I don't know how long it takes to update. I better change it for my other class before I forget. Is that quiz 6? Change this for Monday. There we go. Remember, the quizzes close at 6 p.m. instead of midnight. Right? So got a lot of students that wait till the last minute. They're like, oh, I didn't know. Well, it's been 4 months, right? Okay, let's see. There we go. That should make everybody happy. And for Thanksgiving, I'm thinking about just taking all the homework assignments and changing the due date till the final exam day. So I don't want to tell you, no, you can't do homework. I'm gonna teach you that, right? So I'll probably end up doing that, just selecting all and changing the due date. All right, so any past homework you didn't have time to do enough, you could still do it. And then you can also access it for reviewing for the final, right? Yes. No. I mean, you could turn it into written work. I'm not sure. I forget what the grading policy is on that. I mean, not like it won't allow you to submit it, right? You can still submit written work and graded work. I think they see this does a like a 70% off or something for being late. But if you look at the syllabus, that's only 2.5% of your grade. The written work and the guided work is 2.5%. Okay. So we were in 13.6. We went through about half of it, right? Did that. And then we're going to do some stuff that is new to me. Did we do this one? We did this one too, didn't we? Maximizing savings. I don't remember. I guess we could do this one. So we could do a recap here, right? We learned last time that profit is revenue minus cost, right? If you differentiate both sides, you get this. If you're maximizing profit, right? The maximizing profit, you take the derivative, set it equal to 0, and solve, right? So profit is maximized when marginal revenue is equal to marginal cost, right? Marginal revenue is the revenue you get if you sell just one more. Marginal cost is the cost of making just one more. So if making one more costs the same about as the money you make by selling one more, that's your break-even point. So after that, if you make another one, the cost of making that next one is going to be more than the revenue that you get from selling it. You don't want to make anymore. So that's your break-even point. That's where profit is maximized. So this is the same thing, but they kind of word it differently because we're talking about savings here. So we have this new manufacturing process in a plant, all right? And we can have this savings, right? This new process saves us some money, right? But over time, the savings goes away. So it starts off at 100 on our initial savings, right? But it declines with time. So as time passes, it gets less and less than 100. But the other thing is that as time passes, the cost of the new process increases. So at first you get this like great savings, but that savings slowly peters out, right? But there's a cost to the savings, and that cost to getting that savings increases over time. And eventually the savings you get and the cost of getting those savings are going to equal one another. So when they're equal, that's when you want to stop using that new process because the cost of the process is more than the savings that you're going to get. Okay. So step one, to maximize the savings, you want to set these equal to one another and solve for x. Well, these are both just quadratics. Y'all know how to set those equal to one another and solve, right? It's a basic quadratic formula. Here's a nice pretty graph. All right, so you set them equal to one another, it's solved. You can see like it's like 6 or whatever. Right here, them set equal to one another, and they've already got it written out all pretty. Go ahead and copy and paste that in here. In this case, they factor. You could use the quadratic formula, right? Set them equal to one another, move everything to one side, make sure that everything is equal to nothing, right? From here, factor or use the quadratic formula. And then you solve, you can see that either x is 6 or x is negative 25 thirds. This one doesn't make any sense, right? A negative number of items. We don't consider that. That doesn't make any sense. So x is 6. Where's part B? Part A. It's B here. There is more. There we go. So here's the same picture, but drawn on an Atari 2600 for some reason. I don't know why they bother with that. Let's look at part B. Now, taking the additional costs into account, how much will the company actually save during the 6-year period? So we found, use the saving process for 6 years. All right, that's when it maximizes the savings. Okay, the actual savings is the difference between the savings and the additional costs. All right, so we're going to need integral of the, is that what they call them, S prime and C prime? Yeah, the difference between the two, dx, and we have to go from 0 to 6 years. All right, so that's your basic integral, and these are both simple polynomials. Y'all know how to integrate those. But in case you don't remember, let's paste these in here. Your net savings, all right? Here's your savings minus the cost of the savings for 6 years. All right. Combine these. I collect like terms first. All right. And then integrate. You know how to integrate. X becomes x squared over 2. And you integrate from 0 to 6. Plug it in. We get 372. Since it was in thousands of dollars, we're going to save $372,000 over the 6-year period. If you kept trying to use the new technique, you start losing money. Okay. All right, now we're going to get into the present value. I don't know what y'all learned in business algebra class, okay? When I teach at Northwest Vista, well, I guess let's look at this first with basic algebra. Y'all all remember continuous compounding of interest, right? Now remember this formula? If you're compounding interest continuously, well, it starts off with this. Plus r over n to the nt. That's if you're compounding interest n times per year. And if n goes to infinity, this turns into this, okay? So this is the exact same formula, except they're calling the future amount, they're calling it future value. And instead of principal, they're calling it present value, okay? Same formula. If I divide, all right, that's what they have here. PV equals FD over e to the RT. This is your basic continuous compounding of interest formula that y'all should have seen repeatedly by now, right? Okay, then they integrate. Well, what is all this stuff, right? So this is a basic formula from basic algebra. And this is where you put some money in the bank, compound continuously, and at some future time t, you have this amount, right? Well, we want to think about something different. Instead of getting a single future payment of future value dollars, right? Put your money in the bank for 10 years. At the end of 10 years, you have an amount. Great. Instead of that, I want a stream at a rate of FV dollars per year over the next 2 years. So what that means is you're putting money in the bank, and each year you're going to take some money out. All right. So one of the examples we'll do is like, how much money do I need to put in the bank now at this % interest so that each year I can take $10,000 out for 5 years, right? So basically you want to end up with $50,000. You're taking $10,000 out each year for 5 years. How much do I need to put in now given X interest rate? This is like, it's the opposite of annuities. Well, I had to teach the class in college, business algebra. Annuities are like, if I put $100 in the bank each month and I'm collecting, they're compounding interest monthly. So each month I'm putting a little more in, but I'm also collecting interest on what I put in. How much will I have at a future value, right? The opposite of that is I'm going to put some money in the bank, and each month I'm going to take out $100. But the money that I have in the bank is still collecting interest. Right, so that's the inverse of an annuity. I forget what the name of it is. So in algebra class, they're not doing continuous. This is continuous interest here. Compounded continuously. Remember, that's that formula, right? In the other class, we would have like future value, PMT, your payment you're getting, and what was it, 1 plus 1 minus I. God, I can't remember off the top of my head. Hold on. This is related to annuities. Here we go. So this is what it looks like if you're not doing things continuously. If the interest is not being compounded continuously, instead it's being compounded M times per year. So if you're compounding things quarterly or monthly, you get this discrete thing, which is just an exponent, right? But if you go to the realm of continuous, you have to use integrals. So that's what we're doing here. We're integrating. There's two different t's here. All right. This big T is like how many years that you want to be taking money out. All right. The little t is your variable that you're going to integrate over. Okay. So here's your basic formula. Your present value, how much money you have to put in the bank now, so that you can get a future value each year for t years at an interest rate R. So let's write this a little bit bigger. PV, 0 to t, the future value, this is capital T here, lowercase t, e to the minus RT dt. Okay. This is negative if you're taking money out at a certain rate. So an interest rate of R dollars per year. So R is, again, your annual interest rate. So let's look at an example of this. It's basically going to be plug and chug, right? They give you the formula. They're going to tell you the values and you plug it in. So assume an interest rate of 2%, and you have to use the decimal, right? Remember, this symbol just means 1 over 100. It's shortcut notation for 1 over 100. So you don't want to throw a goofy symbol like that into a formula. You convert it to what it means numerically. Okay, so R is 0.02. Compounded continuously, that's why we have the e to the RT, right? Because 1 plus 1 over n to the n turns into e as n goes to infinity, right? So compounded continuously, we get this stuff going on. Find the present value in each of the following situations. All right, we have our formula right up here. So we want to find the present value of a single future payment of $10,000 5 years from today. Y'all know what this is. Y'all use this. All right, if I plug in, I want to end up with $10,000 5 years from today at 2%. We're solving for P. How much do I need to put in the bank to get $10,000 in 5 years if I have 2% interest? So P would be AE to the minus RT. Of course, they're calling this present value and future value, but y'all learned it with these letters, right, in college algebra. So you want to end up with 10,000 bucks at 2% in 5 years. So you just plug that in to your calculator, all right? So part A is stuff you did in college algebra over and over and over again, okay? Part B, so if you plug that in, you see it's $9,048 bucks. So after 5 years at 2% interest, that turns into 10,000. Now part B is where you get into calculus. Where we just have to take that integral, all right? We have our formula. Here's our formula. Let's see what they're asking us. Find the present value of a future income stream of $10,000 per year over the next 5 years. So at the end of each year, you want to take $10,000 out. So at the end of the 5th year, you've gotten 50,000 bucks and there's no more money left. How much money do we need to put in the bank, right? Well, it's not going to be 50,000 because you're collecting interest on the money that's in there, okay? So their FV of T, that's your 10,000. Our R here is still 0.02. All right, our big T is 5. We're going from year 0 to year 5, so you have to replace that with a 5. And the little t is your variable because you're integrating over time. Okay, so if you plug this into your calculator and integrate it, you're going to get 47,000. So you put 47,581 cents in the bank at 2% interest. That means you can take $10,000 out at the end of the year, each year for 5 years, which means you got 50 grand, right? So you're still making 2,500 bucks, right? Because often we don't want to just put money in the bank and let it sit there, and then the day before we die, take it all out, be like, score, right? you kind of want to like tap into that, once you're retired and stuff. You want to tap into your savings and use it, but not all of it, right? So you want to be able to project how much money you'll have in a given amount of time. Okay. This is useful math for anybody. This here, all right, I'm new to this, consumers and producers surplus. So it's taking me a little while to get my mind wrapped around this. Let's scroll down a little more. Okay, again, we're going to have the basic formulas. So whenever you do your homework, you just plug and chug into these formulas. There's a few steps here, but the market determines the price at which a product is sold. Okay. As indicated earlier, the point of intersection of the demand curve and the supply curve gives the equilibrium price, right? So when supply and demand are the same, right, that gives you the price at which you can sell something, right? The equilibrium price. Consumers will purchase the same amount of the product that manufacturers want to sell, all right? So everything you've made gets sold. Some consumers, however, will be willing to spend more for an item than the equilibrium price, like the Tickle Me Elmo, right? Things like that. The total differences between the equilibrium price of the item and the higher price of all those individuals who would be willing to pay is called consumer's surplus. All right, so let's see, how can I interpret this? So some people spend more than the equilibrium price. The difference between the equilibrium price and the higher price is called the consumer surplus. So that's how much more people are willing to pay than the equilibrium price. Okay. So over here in our little picture here, here's our demand curve, right? And then we have a red box and a blue box. The P naught here is the equilibrium price. The Q naught here is the called the equilibrium, the quantity, the equilibrium quantity, right? How many you want to make. This is how many you want to make where demand and surplus meet, okay? So first, you're going to want to find that out, like how many do I need to make, because that's how many I'm going to sell at equilibrium, okay? So if this is the equilibrium price and this is the equilibrium quantity, right, this area is going to be how much money you're basically making at the equilibrium price, okay? So let's see. So the total shaded area, red and blue under the demand curve, is the total amount consumers are willing to spend for Q naught items, both under the equilibrium price and above the equilibrium price. So the blue here, well, I guess I should do red. The red area, the total amount consumers actually spend at the equilibrium price of P naught, right? So it's just a square or a rectangle, if you will. Q naught items at P naught price. The blue area represents the consumer's surplus. This is how much money you're making by selling items at higher than the equilibrium price, okay? So in order to figure out what blue is, you need to take this integral and subtract this integral. So that's what this is right here. D of Q, and then you're subtracting P naught. All right, so that's your consumer surplus. And notice you're integrating from 0 to Q naught. You're integrating from 0 to here, okay? So given a word problem, first you need to find out what Q naught is, then you find out what P naught is, and then you can integrate. Once you know P naught and Q naught, you plug them into your formula and integrate over Q, and then you can find your consumer's surplus. Now there's another one though, producer surplus. So consumer surplus is people buying stuff over the equilibrium price. Consumer surplus or producer surplus is when you have a surplus of stuff and you have to sell it under the equilibrium price. Okay, so here the graph looks a little different. So S here is supply. The total difference between the equilibrium price and the lower price at which manufacturers would sell the product is called the producer's surplus. All right, so the red area is the minimum total amount manufacturers are willing to realize from the sale of Q0 items. So this is like if people always pay the full equilibrium price, right? But no more or no less. All right, the total shaded area red and blue is the amount actually realized. So this is selling at equilibrium price, and this is if you start selling under the equilibrium price, you get a little bit more out of it, right? So here's our supply here though. So it looks a lot like the last one. These are like reversed, right? But you can see why we need to do P naught minus S. So here's our P naught, subtract off the S, and then we get our producer surplus. So again, you still need to find P naught and Q naught. All right, if you have those, then you can still find the producer surplus. So the examples or the word problems you're going to have, find the Q naught, find the P naught, plug it into your formula. I don't know why I'm so hyperactive today. I didn't get much sleep. I kept thinking about underwear. Not in a dirty way. It's like, why do we call it a pair of underwear? I understand a pair of pants because each leg, this is called a pant, right? There's two of them, but underwear doesn't have legs. So why is it called a pair of underwear, right? Furthermore, why would I say I'm wearing underwear? If it's a pair, why don't I say I'm wearing underwears, right? But it's like I don't say I'm wearing shirt. I say I'm wearing a shirt. So if we're going to stick to singular underwear, why don't I say I'm wearing a underwear? Like the grammar doesn't add up. It's inconsistent every way possible. I'm guessing that underwear used to have legs, so that's why it would be called a pair of underwear. So, but if that's the case, why don't we call it underwears? If that's the case, it's just it irritates me. I can imagine like trying to learn English. Like if it wasn't my first language, I'd say everything wrong. Yeah. Mm-hmm. George Carlin had a whole series on that, like near misses, right? Like that means it should be a near miss if you missed, right? Uh, or yeah, near miss should have been a near hit, right? Yeah. Okay. All right. Let's see here. Let's do this example here. Try to keep our brains from oozing out of our head. Did y'all do like annuities and amortization in your business algebra? What I'm teaching at Northwest Vista, it's like there's like 4 like formulas for basic finance stuff, but they take them and just run them into the dirt. They make simple interest as complicated as I've ever seen in my entire life. I assume y'all be doing that in your other business classes. So then here we're just in there. It's difficult because like the math is so hard. It's like I wish y'all had calculus. You could do this in just like one step, but instead they have to do like pages and pages of algebra. Yeah, yeah. All right. Suppose the price in dollars per ton for steel cut oatmeal is given by D of Q. So I'm seeing a price, but they call it D. So this is demand. So this is the price you can sell it at demand Q. Yeah, the demand for the product is Q tons. So I find this confusing because this is a price, but it's demand, right? Also, the function S of Q gives the price when the supply is Q tons. So both of these are prices, but one's based on demand and one's based on supply, okay? Find the consumer's surplus and the producer's surplus, all right? You have to find the equilibrium quantity. That's when demand is equal to supply. So you set those two equal to one another. You have this quadratic in Q, and you solve it like you normally would. You can either factor or use the quadratic formula. So these quantities are your equilibrium quantity. course, the negative number doesn't make any sense. You can have a negative quantity, right? So we throw that out. So Q is equal to 15. We would call that Q naught, what we call it in the formula. All right, let's express this. All right, so here we go. Q naught's 15. So what is the equilibrium price? Well, S gives you the equilibrium price. I'm trying to figure out why we don't plug it into D. Why do we plug it into S? All right, I guess because they're both price, right? Suppose price is this. No, wait, this gives the price for Q tons. So apparently use this based on your supply, right? You find the equilibrium quantity, that's how much you make. So that's your supply, right? So we're going to use that to figure out the equilibrium price. So we get $375. So that's going to be our P naught, our equilibrium price. Use the supply, not the demand. Okay? Verify that the same answer is found computing D of 15. Okay, well that's good. That is where they're equal, right? So you can plug it into either one because we basically set those equal to one another, solve for Q. So plug it into either one. That makes sense to me now. I was worried, like, why is it only this one? It should be both, right? If you plug in 15 here or 15 there, that's where they're equal. That's what we just solved, right? So the consumer surplus, you take your demand. Well, here's our basic formula, right? Take the demand minus the equilibrium price and then integrate from 0 to Q naught. So we're integrating over Q here. So now that we know, so we don't need P naught yet, do we? Yeah, there it is, P naught. Boop. Once you have P naught and Q naught, there's our Q naught, our P naught. Plug them in and integrate, and that's going to give you your consumer surplus. Here's our nice little picture. So there's our demand decreasing over time. Here's our supply increasing over time as we make more and more. So we're finding the consumer surplus here. Here's our Q naught and here's our P naught at 375, right? So which one do we just do? Consumer surplus. So we did this integral minus this integral, right? See it right here. D minus P naught. D minus P naught gives us the consumer surplus. All right, so that again, consumer surplus is the money you make for consumers paying more than the equilibrium price. Okay, and you could do the integral, it's a basic integral, and we get 4,500. So that's how much money you're going to make from people overpaying for the product. I tried singing like Christmas songs to my daughter yesterday, but I couldn't remember any of them. I get started, I'd be like, Frosty the Snowman, something, something, something. Like jingle bells, jingle, and the Joker ran away. I'm gonna have to work on that. She loves the Halloween stuff, all the Halloween lights and the pumpkins and all that. The house down the road had a whole bunch of Christmas stuff, and she was all freaked out and scared of it. She just love Halloween and all that, but the Christmas stuff, no way, no way, she says. All right, the consumer's surplus is 4,500. All right, we just did that. Producer surplus. All right, so we know what P naught is, we know what Q naught is. You plug it into the formula and we get 3375, which is going to be this guy. So you're taking the P naught, it's subtracting off S. All right, so P naught subtracting off S is supply. And we get 3375. So that's how much you're going to make from people overpaying for the product, right? No, underpaying because you have a surplus. So they're paying less than the equilibrium price. And that's it for 13.6. 13.7 is differential equations, but as far as I got in the last class, it's just the same stuff we've been doing. Right? You integrate dy, you get a function plus c, and then you use some information to solve for c, and ta-da. So it doesn't seem to be anything new so far. Like there's entire classes called differential equations 2. Right? There's lots of, and here it's all like one variable, so things are easy. So y'all know you could take the gx and you could put it over here, and then you integrate both sides. So y is equal to this, and then you get some function plus a constant. You solve for the constant, right? We've been doing that over and over again. So that's what they did right here. They moved the dx over, and then they integrate, right? So there, and then you get this constant. So y'all are used to solving equations, and the solutions are numbers, right? Well, what we did here by integrating both sides, the solution is a function. By doing the antiderivatives, we're solving equations where the solutions are functions instead of a number. Okay, that's what we've been doing when you do the antiderivative. And this constant here, the c, means there's an infinite number of solutions. You keep changing c and you have a different function, right? It's really the same function, just moved up or down. See, there you go. Here's your picture. All of this is just the same function, but you're just moving it up and down, different c values, either 2, -2, or 0. That's all it is, right? And y'all have seen this over and over again. So your general solution, instead of actually taking the integral and writing it as plus c, you can just leave it in integral form, right? Y is the integral of f of x, right, which we call big F plus c. Just leave it like that. Population growth. So this is no new math so far. Population P of a flock of birds is growing exponentially, right? Find P in terms of X. If there were 20 birds in the flock initially, this tells us that P of 0 is 20. Well, dP is going to be the integral of 20e to the 0.05 x dx. Well, no. There. Move the dx over and then integrate both sides. I mean, mathematically, just to move this over here, it's like, that's not right, but it's totally right, okay? Mathematically, they'd say, no, you can't do that because this is an algebra, right? But it works exactly the same way as algebra. Again, dx is an infinitesimally small quantity. But in here, you could just treat it like it's just any quantity because we're doing very simple math, all right? We're not doing it where the mathematicians should throw a fit, right? Physicists and business majors can do that. Mathematicians can't, even though it's equal, okay? So this is P. So this is our general solution. So y'all know how to integrate. This would be 20e to the 0.05x divided by 0.05 plus a constant. So we know that P of 0 is 20, and P of 0 is this with x replaced with 0. So this is just 1. So looking at that, we see that C has to be 20 minus 20 divided by 0.05, whatever that is. Once you figure out what that is, plug it in here. And then you have what P of X is. All right, same thing we've been doing over and over and over, right? So here is the solution written out all pretty. Let's see, did I open up the assignment or why is it only that one? Let's see. For 13.7, I forgot. Manage. this is the wrong class. $13.7. See, it doesn't open up until the 28th, so let's change that. All right, let's open it up now so that you can work on it, right? How else are you going to turn in your written work if it's not even open to do that, right? Wrong button. I'll open up 2 days ago or something. There, now you can at least start working on 13.7, right, if you want to. There we go. Okay. Where was I? Y'all know how to do the integral. So you use the fact that p of 0 is 20. So we get c equals negative 380. Replace the c with the negative 380, and then you have the p of x. Basic vocabulary. Come on. Fine. So if you figure out what p is, or what c is, and plug it in, that gives you a particular solution, right? And we found the particular solution by noting that when x is 0, p is 20. That's called an initial condition. All right, so like in cosmology, you talk about the Big Bang because the universe has been expanding and expanding, right? So if you go back in time, the universe has been shrinking and shrinking, right? So if you look at the visible universe as opposed to the whole universe, the visible universe is 96 billion light years in diameter. All right. Anything further than that, we don't know about because there hasn't been long enough time for light to reach us. Okay, so you can only look so far away. All right, so if you have an old TV that's having static on it, the old static TVs, right? Like 1% of those little dots are photons of light that have been traveling since the beginning of time. So it's like, well, what happened before that? Right? Well, our equations can't tell us, right? So if you think about the visible universe and let it shrink, it would shrink into a point, right? But the thing is like that's not the whole universe. The universe is infinite in all directions as far as we can tell. So even though if you take a finite amount of it, our visible universe, and let it shrink to a point, there's still an infinite amount of universe around it. So it's not like the whole universe popped into existence. No, just our little visible portion of it, of sphere, of radius, whatever, 96, 37 billion, well, diameter of 96 billion light years, that shrinks into a point, but there's still an infinite amount of universe around us. It's not like everything just came into existence all of a sudden. It's been there for an infinite amount of time. It's just our region of the universe that came into existence 13.8 billion years ago. Well, we know about the universe for this time, where time today is 13.8 billion years. All right. We don't know this. We know the round bracket. We know what happened a trillionth of 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 a second after the Big Bang. We just don't know what happens exactly at the Big Bang, because right there you're dividing by 0. So just because science doesn't know yet, it's because our equations aren't sophisticated to tell us. And it comes down to an initial condition and solving differential equations. All right. So sometimes a differential equation must be written in this form. Okay, so we're saying y prime is a function. Y'all are used to seeing y prime as a function of x, and then we solve for x. So here's more of the same. So I will have office hours today, but I'm going to cut out at 2 o'clock so I get to have my daughter, and we're going to the playground. It's so much fun. All right, so here, find the particular solution. Okay, well, you could say, okay, move the 3x over, right? So we would have 3x plus 7, and then multiply both sides by dx, right? So I would say, okay, well, y, the integral of dy, would be the integral of 3x plus 7 dx be 3x squared over 2 plus 7x plus some constant, right? This is obviously some function of x, right? We don't even need to write that. And then they say, okay, well, if this is what y is, plug in 2 here and plug in negative 2 there and solve for c, right? So you'd have 2 equals 3 times negative 2 squared over 2 plus 7 times negative 2 plus a constant. I don't know, what is this? The minus squared goes away. 3 times 2 is 6, minus 14. So c is 16 minus 6, c is 10. So place that with a 10, and you have y. So the solution to this equation is a function, not just a number. But this is stuff we've been doing for months now, right? Right? Nothing new? Okay. And here we go. This is where I left off in the last class. So I'm going to try to keep y'all in sync still. Y'all have any questions about anything? Any requests, demands, suggestions? Somewhere in Blackboard, y'all are supposed to do a student survey, I think, for all your classes. I think it's under tools. You go to tools, you can do a survey. Tell me how I did. Give me some constructive criticism, things I could do different, do better. All right. So if you have questions, I'm heading to my office at 2 o'clock. If nobody's there, I'm taking off. All right. Y'all have a good rest of your day. Next week, Zoom. Monday we'll do Zoom, and we'll do the practice test on Monday, and then Wednesday will be the test. So we won't even Zoom on Wednesday. Yes, ma'am.
I think it was on Monday.
Wolfram Alpha. That is Wolfram Alpha.
Like, that's going to be one of the problems, and I couldn't find that website because I couldn't do it on Mathway.
Halfway would do it.
No.
Yeah, do Wolfram Alpha. It's from Stephen Wolfram, who invented Mathematica. It's just a college computer algebra software.
Thank you.
Oh, and it has an app too. Yeah, you can download it. And if you pay $10 a month, it'll show you everything step by step as well. For the pro version.
When is the final day?
I don't remember off the top of my head. UTSA's website should have a final exam schedule that tells you when all your finals are for every class.
Next Friday, but then you start up there.
Yeah, I don't know. Go with whatever UTSA's website says, because the syllabus might have come from the Tuesday, Thursday class transferred over. Okay.
Was it going to be online or?
I'm thinking it's going to be online, just like the rest of the exam. Yeah, it's because it's going to be through my math lab.